Hello! In this video, we'll be talking about what makes a shortcut. And in my opinion, we should have three criteria. The first one is it has to be short, obviously. The second one is we should be able to do the work in our head. So that way, if you're a guy, you can impress girls. And if you're a girl, you can impress guys. Great, huh? And then, the third one is the shortcut has to always work. Otherwise, it's just false advertising. So have a look. If I tell you the fastest way to reduce 16 by 64 is just to reduce out the 6 and we get 1 over 4. How would you feel? Well, anyway, I'm going to show you guys how to do some shortcuts with all these questions, and then the most important thing is that you should know why and how the shortcut works. Shortcuts are actually just the nice result after some general procedures. So have a look. For the first one, I will demonstrate how we can actually do this in our head, solving this system of equations. To get x, we can just do the following. Well, you do 4 times 12, which is 48, and you minus 7 times -1, which is -7. 48 minus -7 becomes 48 plus 7, which is 55. And then you divide it by this times that, which is -3, minus this times that, which is 8. Minus 3 minus 8 is minus 11. 55, you divide it by minus 11, but you make the negative out of that, so actually get positive 5. You have to negate the result, right? So x is equal to 5, and y is equal to the following. You don't have to negate the result. You can just go ahead and do this times that, which is 36, and then minus this times that, which is 14. 36 minus 14 is 22. And then you divide it by the same thing. This times that, which is -3, minus this times that, which is -8. So earlier we got 22 over -11, and you do not have to negate the result. So you just have x is 5 and y is -2, and you are done. All right, the second one is partial fraction, and namely we are going to find out the value for a and b. All right, so I will just show you guys right here. A is equal to the following. Well, to get a, you see that this has the denominator x plus 2. And just have to ask yourself, how can you make x plus 2 equal to 0? Which is -2, right? All right, so you come back here, you cover this up, and again, x has to be -2. And you put -2 in here, and just work that out. So 8 times -2 is -16, plus 7 should be -9, and then divided by this right here is -2 minus 1, which is -3, -9 over -3, we just get positive 3. Right? All right, and then for b, well, the denominator is x minus 1. We come back here, cover this up, and how can we make x minus 1 equal to 0? X has to be 1, yeah? And then just put a 1 in here and here. So you see, 8 times 1 plus 7 is 15, over 1 plus 2, which is 3. 15 over 3, we get 5. And then with that, we are done. Just like this. Okay, for the last one right here, it actually works with complex numbers as well, but let me just do this for you guys. Whenever you have the question set up to be like this, namely, we have a nested square root, a square root itself, another one. In particular, notice that we have a 2 times the square root. In that case, you can do the following. Can we find two numbers, they add up to be 7, which is this number, and then they multiply to be 10? Well, yes. If so, you can actually write this in terms of a square root minus another one. Well, what's a combination though? Namely, we will have to get 5 and 2, because 5 plus 2 is 7, and 5 times 2 is 10. And because this is a minus, you write down the minus, and minus matters. So you are going to make sure that you put down the bigger number right here and the smaller number right here, because the output of the square root, it has to be positive. And earlier, as we discussed it, we should have 5 and 2. And then you are done. Just like this. And again, let me tell you, this also works with complex numbers as well. So you guys can go ahead and try that. But anyway though, I think these are really cool, and utilize this whenever you can. And of course, this is not it for the video. I will tell you guys why these are true. Again, remember, what makes a shortcut is that a shortcut is actually just a nice result after a generalization, right? Of a generalization of the certain things that you will have to do over and over, such as this, such as that. If you only have to do one of them in your life, you probably don't need to use a shortcut for that. You will just do it and then you're done. But you know, how many times do you have to solve a system of equations? A lot, right? Especially the 2x2 situation. So let me show you why that works. And of course, I didn't come up with this technically, Cramer did. But if you look at the following, based on the way I presented, you can actually try to figure out shortcuts on your own as well. So, how to solve a system of equation? Have a look. Well, the key is, right here we have the coefficients, and you see that the x, y, and the number are all lined up nicely. So, the general form is the following. We will write it as ax. A is just some constant, and then also by, and then that's equal to some other constant c. So, same idea, right? And then for the second equation, well, we'll just use more constants. So the next one is going to be dx. Well, this is not derivative, so if you are taking calculus, don't be too excited. All right, plus the next is ey, and lastly we have that's equal to f. So a, b, c, d, e, f, they are just constants. And now here is the deal. I'm going to solve for x based on this, and I'm also going to solve for y based on this. Let's proceed by solving for the x first. And I will do it by elimination. And to do so, I'm going to multiply the first equation by e. And then I'm going to multiply the second equation by negative b. Why? Because later on they will have the same coefficient but opposite sign. So when we add them, they will cancel out. And you'll see this right here is just going to give us a e x. And then we have plus b e y, and then this almost looks like eBay, but no. Anyway, this is equal to CE, and then the other one we have negative b dx minus b e y, and that's equal to negative bf, right? And then, based on this, if we add them up, they cancel, and we just have this is equal to that. Have a look. They have x, so we can just put the coefficients together, and you will see though, we have ae minus bd times x, and that's equal to this and that, namely ce minus bf. And of course, we can just divide this on both sides, and you see x is equal to ce minus bf over, and then we have ae minus bd, like this. All right, and you might be thinking about, man, this is really crazy. Now, who is going to remember this little formula, right? Well, yes, I will agree if you just look at CE minus BF divided by AE minus BD. If you just try to memorize this as how this is, it's going to be bizarre. I will totally agree with you. But this right here is actually not so bad if you look at the positions of the numbers from the original system of equations. Have a look. CE minus BF, where's CE? Well, CE just this times that, right? CE. And then minus BF, which is this, right? But notice the way I did it earlier, I approached it as I did this times that first. So this is the first thing I did. And then I multiply this and that. That's the second thing I did. So I kind of switched the order of the subtraction. That's why I needed to negate the result. And the purpose for me to do that is because that way I can be consistent. And of course, if you remember the CE, right, this times that, the diagonal, and the minus this times that, the diagonal, you don't need to negate the result like how I did earlier. Well, where is AE minus BD? This right here is just from here. A times E, and then minus this times that. Have a look though. If you have AE minus BD, you are talking about this times this first. This is the first multiplication, and then that. That's the second. And in my opinion, I want to have things to being consistent. That's why you see on the top here, CE minus BF. Earlier, again, it was this times that go first, and then this right here goes second. I didn't like that too much, so I like to do it as BF right? BF and then minus CE, and then divided by AE minus BD. But again, just like what I mentioned earlier, in the end, we have to negate the result. Yeah? So it's like you just do this times this, that's the first, and then that's the second multiplication, right? And then the second thing you have to do is just divide the front part, which is like this times this, and this times that. And in the end, just remember, if you are solving for x, you will have to negate the result. All right, and now let's see what if we have y, right? So for y, same thing. I'm just going to write down the equation again. So we have ax plus by, that's equal to c, and then man, I don't know my alphabet. Dx plus ey, that's equal to f. Well, to solve for y, I'm going to get rid of the x, and to do so, I will multiply this by d, and I will multiply this by negative a. And you will see that this right here becomes, well, I like to draw my brace. Anyway, we get a dx plus b dy, and that's equal to cd, and then the other one is negative a dx, and then minus a ey, and that's equal to negative af. All right, when we combine these two equations, they cancel pretty nice, and then you see this right here becomes bd minus ae times y, that's equal to cd minus af. Yeah, pretty good, huh? And now y is just nicely equal to cd minus af divided by bd minus ae, like that. Well, again, don't try to memorize the cd, ae whatsoever. Try to memorize, or I don't like to use the word memorize, because the word memorize doesn't have a feeling. I like to use the word remember. What do I mean? Just imagine, maybe right now you just graduated from high school or college. After 5 years, you bump into your friend in college, right, on the street or something. Are you going to tell the friend that, hey, I memorized you from so-and-so class? I hope you don't do that. That doesn't have a feeling at all. You will say to him as what, or her as what? Hey, I remember you from so-and-so class, right? So that's the idea. So let's remember the position of the multiplication rather than the ABCD, right? Okay, you see that we have CD, so it's this times that, and then minus AF, which is this times that. Again, this is the backwards, just like what I told you earlier, right? So if you don't want to do that, if you want to do this direction so that everything is just going to be from left to right, and then right to left. In that case, what I'm going to do is just switch the order of the subtraction. But you will see that, well, I just have to negate the result on the top, and then I can put this down as AF minus CD, and then divided by, I want to do AE times this, because that will be exactly what we have here. So again, I will also switch that, and we get AE minus BD. All right, in the end, we see that this is just AF minus CD over AE minus BD. Have a look. AF is this times that, so you have this times that, right? AF. And then we are just going to do C times D, which is like this. That's the second multiplication. And then we just divide it by, well, what we did earlier, which is AE, like this, and then BD, like that. Right? So that's pretty much it. And again, if you remember where to multiply and divide, and don't forget, if you do it this way, x has to be negative of the result right here, then I'm pretty sure that you can impress people because you can solve a system of equations in your head. Provided that the system of equations does have a solution, because, you know, sometimes it just does not. All right, for the second one, I would like to go over what we call the partial fraction. So the second one, we have the 8x plus 7 over 8. Sorry, I'm just looking at the question that I put on earlier. x plus 2 times x minus 1, like this. Well, whenever you have this kind of situation, the bottom is a product of two linear factors, meaning that this is x to the first power, x to the first power. You can break this down as some number a divided by the first factor, and then you add it with some other number divided by the second factor, like this. Provided that the degree on the top is lower than the degree on the bottom. The degree right here is 1. The degree on the bottom is 2. So this setup will work. Alright, so why did that work? Let's review this real quick. To solve for a, what we did is look at the denominator, go back to the original, cover the same denominator up, and you ask yourself, how can you make x plus 2 to be 0? X has to be negative 2. And then you put negative 2 in here and here, and you see a times negative 2 is negative 16 plus 7 is negative 9, divided by negative 3 altogether, so you end up with positive 3, right? Super fast, super good, super nice. Now, why does this work? Don't we want to prevent the denominator to be 0? Let me show you. Well, the idea of covering this up is the following. Look at this again. What I'm going to do is, I'm going to multiply everybody by just this denominator, namely x plus 2. And again, our goal is to figure out a and b, right? So anyway though, if we do that, then when we multiply this with this, what we just get is 8x plus 7 over x minus 1. This right here, they cancel. And then this times that, we'll just get a, and then we will just add b over x minus 1 times x plus 2. They don't cancel. So you still have this right here. And now, we are trying to find out a and b. The x, we can just plug in whatever we want. What's a nice number for us to use? Yes, negative 2, because we can make this part equal to 0 if x is equal to negative 2. So when we make x to be negative 2, you will see that 8 times negative 2, and then we just add a 7 after that over negative 2 plus 1. That's going to give us a right away. And then you'll see that when we put the negative 2 right here, negative 2 times this will make the whole thing 0. So you don't have to worry about that. And as you can see, a is equal to this, which is exactly what we did. All right? Very cool, huh? And now we can actually do the same thing. But if you want to figure out b, we will have to multiply by x minus 1. Right? Same idea. Let's multiply everybody by x minus 1. In that case, the left-hand side becomes 8x plus 7 over x plus 2. And then the right-hand side is a over x plus 2 times x minus 1. But this times that, we'll just get a b. And now, what's the good x value for us to use? Yes, positive 1, because that will make this equal to 0. So that's very nice. Plugging x is equal to positive 1. You see, we will just get 8 times 1 plus 7 over 1 plus 2. That's equal to, put this right there, that will make this right here a 0. And then we'll just get a b on the right hand side. And that's exactly what you can do. And let's just finish this. This is 15 divided by 3, which is 5. Alright? And again, for all this, if you practice this few times, you can do all this in your head. So is it worth it? The time that you just try to practice this, you can impress people? I think it's worth it, it's fun. Leave a comment down below, let me know. Alright, the last one. By the way, I'm drinking this just to show you guys. Not sponsored, unfortunately. Alright, for the last one. This is how you deal with like a nested square root. The idea is, whenever you have a square root in the following form, the form is a plus b, and then you add it with 2 times the square root of ab. This right here is actually equal to square root of a plus square root of b, like this. Provided that, of course, if you don't want to have any complex numbers, then a and b have to be non-negative. Well, earlier the example we did was negative here. If it was subtracting, it just made that a subtraction. That's all. So why does this work? Let me just prove this right here for you guys real quick. Because when you have square root of this right here, I can look at the a as the square root of a squared, like this, square root of a and then square, right? And then I'm going to put this part in the middle, so plus 2 square root of ab. And then I will just add it with b. I will look at that as square root of b and then square. You see, they cancel. This is the same as the original. The beauty of this is that the inside is a perfect square. So you end up with the square root. The first term is just square root of a, and the second term is just square root of b. And you just square that. Square root, square, cancel, and you just end up with square root of a plus square root of b. So again, whenever you have the nested square root in the form of, pay attention to the 2 right here. The number here plus 2 times the square root of ab, you can actually just do that to figure it out. Remember the equation that we did, not the equation, the square root that we did was square root of 7 minus 2 square root of 10, right? So you see, all we have to do is just square root, and then you maintain the minus and the square root. And you ask yourself, is it possible to find 2 numbers? They add up to be 7, and they multiply to be 10. And the answer is yes, namely 5 and 2. And again, just as what I said earlier, be sure you put down the bigger number here and a smaller number here, especially if you have a subtraction, because the output of the square root has to be positive. Right? So this is just an example, the one that we did, and then I'll give you guys another example, because you might be wondering, what if we have a complex number? So this is like a little bonus for you guys. I'll just put this down as the little bonus. Bonus. There we go. All right, let's look at square root, and I will tell you, suppose we have negative 1 plus 2 I square root of 6, like this. And right here, I'm just taking the principal square root, right? So this is just the positive square root, right? Okay, so here's the deal. This right here is a complex number, but the I, you can look at that as square root of negative 1. You can put this inside, and you can look at this as square root of negative 1 plus 2 square root of negative 1 times 6 is negative 6. This is in that form, so you can just go ahead and ask yourself, what plus 1 will be negative 1, and multiply, they become negative 6. And the correct combination is 2 and negative 3, right? I will enter 2 right here and negative 3 right here. But negative 3 in the square root, that will give you a complex number. So the final answer is square root of 2 plus I square root of 3. And one more time, I'm just taking the positive square root of this, the principal square root. So I just have 1 square root. And if you want to find out all the square roots, you can just put on a plus minus in the front. But I'll leave that to you guys. Alright, so hopefully you guys all like this, and leave a comment down below and let us know what is your favorite shortcut. Maybe in algebra, maybe in geometry, maybe in calculus, right? And I'll see you guys in the next video. Bye.